Hello and welcome back to the Master Civil Engineering. And in this video, we will learn that how to find the axial stress in a composite material. I have been given a question which says that the steel pipe is filled with concrete and is subjected to a compressive force of 100 kilonewton. We have to determine the average normal stress in the concrete and the steel due to this loading. This pipe has an outer diameter of 85 mm and an inner diameter of 75 mm. Modulus of elasticity of steel is 200 gigapascal and for concrete it's 24 gigapascal. You can see this pipe, okay, which is filled with concrete. It has a length of 1000 mm and loading of 100 kilonewton is applied to this pipe. Okay, we have to find the stress, that is the axial stress in the steel and the concrete respectively. So outer diameter for this pipe, this is 85 mm or 0.085 meter. Inner diameter is 75 mm or 0.075 meter. Cross sectional area of the steel, this will be pi into square of outer diameter minus square of inner diameter divided by 4, which is pi into 0.085 square minus 0.075 square divided by 4, which is equal to 1.257 into 10 raised to the power minus 3 meter square. Cross sectional area of concrete, since concrete is filling the inner portion of this pipe, so its diameter will be equal to inner diameter of the pipe. So cross sectional area of the concrete, this will be pi into 0.075 square divided by 4, which is 4.42 into 10 raised to the power minus 3 meter square. Modulus of elasticity of steel, this is 200 gigapascal or 200 into 10 raised to the power 6 kilopascal. Modulus of elasticity of concrete, this is 24 gigapascal or 24 into 10 raised to the power 6 kilopascal. After that, we will draw the free body diagram for this pipe. Okay, so let us assume that PST and PC, these are the axial force and steel and the concrete respectively as shown in the FBD. Okay, and we are assuming the direction of both these forces to be in the upward direction. Okay, so for equilibrium of forces, assuming that forces in the upward direction of positive and in the downward direction on negative, we can write that PST plus PC minus 100 kilonewton, this is equal to 0. Or you can write this PST plus PC is equal to 100 kilonewton. Let it be equation first. Okay, from the compatibility condition, since this pipe is fixed at bottom, so displacement of concrete and steel will be same. Okay, this is from the compatibility condition. So you can write displacement of steel, this is equal to displacement of concrete. Displacement of steel, this is PST into L divided by AST into EST, and displacement of concrete, this is PC into L divided by AC into EC. Putting values, okay, so PST, since length of this bar is 1000 mm out of 1 meter, so for L this is 1 meter, and it is same for steel as well as concrete. So area of cross sectional area of steel, this is 1.257 into 10 raised to the power minus 3. Young's modulus of steel, this is 200 into 10 raised to the power 6 kilopascal. Cross sectional area of concrete, this is 4.42 into 10 raised to the power minus 3, and Young's modulus is 24 into 10 raised to the power 6 kilopascal. This gives me that the value of PST, this is 2.37 times the PSC. Now you will put the value in equation first, okay, which was that axial force in steel plus axial force in concrete, this is 100 kilonewton. For axial force in steel, you will write as 2.37 times axial force in concrete plus PC, this is equal to 100. So you will get the value of axial force in concrete as 29.67 kilonewtons. Okay, and if you put this value in the first, okay, you will get the value of PST equal to 70.33 kilonewton. Okay, so axial force in concrete is 29.67 kilonewton and axial force in steel, this is 70.33 kilonewton. Now after finding the axial force, you can easily calculate the stress in steel and concrete. So stress, this is axial force divided by the cross sectional area. So stress in steel, this is PST divided by AST, so it will be 70.33 into 10 raised to the power 3 divided by 1.257 into 10 raised to the power minus 3, which is equal to 55.2 megapascal. And similarly, stress in concrete, this will be axial force in concrete divided by the cross sectional area of concrete. So it will be 29.67 into 10 raised to power 3 divided by 4.42 into 10 raised to power minus 3, which is 6.7 megapascal. So this is how you can find out the axial or normal stress for a composite material. You just have to apply the equation of the compatibility. Okay, I hope this solution video was clear and effective, and you definitely learned something new from this video. If you still have doubts, okay, you can write them in the comment box and I will be happy to answer all of them. Thanks for watching my videos and stay tuned.